third and last video of this series, sketching transformations, given the graph of the original function. In this video, we graph only two advanced examples. Unlike before, where we can immediately identify what the transformations are, we first need to do something. We need to rewrite the given in this form. Okay, so let's do the rewriting for the first example. We don't have an a, well, a is just 1 and d is just 0. So what we need is the b factored out. In our case, that b is 2/3. And if you factor out the b, this number over here is 3/2. So if you're wondering, how do you get this number? It's this divided by that. Okay, that's how you get that number. We can stop here. I'm going to tell you now that this can be plus or minus c. You can end there. You can end there. We are done with the rewrite. It is now time to identify the transformations. They're both happening inside the parentheses, so they are both horizontal transformations. This 2/3 out here is actually a stretch by a factor of 3/2. And 3/2 is by a factor of 1.5, 1.5. This plus 3/2 right here is a horizontal shift to the left 3/2 units. Okay, 3/2 is 1.5. Let's use this graph. Again, we work point by point. Either go right to left or left to right. So if I start with this point, a horizontal stretch, remember you have to do stretches before shifts. What we're looking to stretch is the horizontal distance. Currently, this point is 1 unit away from the y-axis. To stretch that, 1 unit distance times 1.5 is 1.5. So it stretches, it gets pushed out here. And then you can apply the shift of moving left 1.5 units. Well, if you move 1.5 units left, this point, so it gets pushed out and then it moves there. It shifts there. Next. This point is 4 units away. The horizontal distance is 4 units from the y-axis. So a 4 unit distance times 1.5 is 6. So what used to be a distance of 4 will now be a distance of 6. So it gets pushed here. And then you shift it left 1.5 units. And lastly, this one, okay, I hope we have enough space. This one is 1, 2, 3, 4, 5, 6, 7, 8, 9. It has a distance of 9. And that horizontal distance is what gets stretched. 9 times 1.5 is 13.5. 9 becomes 10, 11, 12, 13.5. And 13.5, you move left another 1.5 units. So this is a half unit, 14, and 1 whole unit, 15. That's where it ends up. It got stretched horizontally and then got shifted to the left. What makes this an advanced problem, other than having to rewrite, having to factor out the 2/3, is it's the dealing with fractions. You might wonder, how do you know this is a stretch and not a shrink? It's very important to know that it's a stretch because 2/3 is less than 1. If you think less than 1 should be a shrink, remember, horizontal transformations are counterintuitive. I've said this before. So a factor that's less than 1 is actually a stretch of, or a stretch by a factor of, get the reciprocal of 2/3. And that's what you stretch it by. Example 2. Negative f of 3 minus x plus 3 all over 2. Here goes the rewrite. If you have a sum in the numerator, you can separate them into 2 fractions over the same denominator, right? So, right, because like a over 2 plus b over 2 is the same as a plus b over 2. So this is kind of our a and this is our b, and what we're doing is we're separating them into their own fractions. This portion can be written as a product. The product of negative 1/2 and f, you would multiply the numerators together, so that would give you negative f, and the denominator of this is a 1. Multiply the denominators together, you would get 2. If you need a refresher, how do we multiply fractions? A over B times C over D. That's just A times C over B times D. Just multiply numerators together and then the denominators together. We're getting closer. I don't know if you can tell, but our A is -1/2. The plus D, or I should say plus or minus D, is already here. We just need to work on this one. 3 minus x is the same as -x plus 3. And finally, again, this has to just be x. This negative needs to be factored out. A times f of b, x minus c plus d. That's the rewrite. We have 1, 2, 3, 4, 5 transformations. The ones inside this negative sign and the -3 are both horizontal transformations. The minus sign is a horizontal reflection over the y-axis. And the -3 is a horizontal shift right 3 units. This negative is its own transformation. The 1/2 is its own transformation, and the plus 3/2 is the fifth transformation. They are all vertical transformations. The negative is a vertical reflection over the x-axis. The 1/2 is a vertical shrink by a factor of 1/2. And this is a vertical shift up, because it's plus 3/2. Up 3/2, which is 1.5 units. Do all the reflections and dilations first, and then the shifts last. Let's use this one. Point by point. So we'll use this point, and this point. Starting with this. I will do it in this order. Reflection, reflection, dilation, shift, shift. Let's go. A horizontal reflection over the y-axis. From here, it goes here. A vertical reflection over the x-axis. From all the way down 6 units, it will go up 6 units. A vertical shrink by a factor of 1/2. It is the vertical distance that gets halved. Next, horizontal shift to the right. -3 means to the right, 3 units, 1, 2, 3. And lastly, a vertical shift up, 1.5 units. Next, this point. A horizontal reflection over the y-axis. Well, it's on the y-axis, its reflection is still on the y-axis. A vertical reflection over the x-axis. 4 units down becomes 4 units up. Third, a vertical shrink. A vertical distance of 4 shrinks by 1/2 to 2. Shift 3 units to the right and 1.5 units up. 1, 2, 3, 1.5. And this last point, horizontal reflection over the y-axis. Goes all the way there. Vertical reflection over the x-axis, it stays. Next, shrinks by a factor of 1/2. There is no vertical distance to shrink. So 0 times 1/2 is still 0, just there. And lastly, shift right 3 units and then up 1.5. 1, 2, 3, 1.5. And yeah. There was a reflection over, okay, so a reflection over the y-axis, and then there was also a reflection over the x-axis. It used to be taller, it got shrunk, vertically compressed, and then it also shifted. Points to remember. Make sure to transform points one by one. Ideally, from left to right, or right to left, okay, in an organized manner. Number 2, rewrite the given. It has to be in the form a times f of b, x minus or plus c, and then plus or minus a d. And lastly, make sure to do all reflections and dilations before any translation, which we also call shift. That concludes this series, sketching transformations given the graph of the original function.